Solving systems. So a system of equation is a set of equations with the same variables that together describe a situation. You should have talked about this in your Algebra 1 class. So you should kind of have seen this stuff, but if not, of course, I'll go over it. So that's a system. So a system is just a set of equations that has the same variables. So it could always be x and y. It could be x, y, and z, which we'll get to a little bit later. You can also have a solution to a system is the point or values when the equations are equal. Okay, so, and I'll show you that in just a second. And then you always write the answer or the solution as a coordinate, and you always write it as x, comma, y. Or if you're using p and t, then you would put p, comma, t. Okay, so that is how you write the solution. Now, there are 3 types of solutions that you will see. So types of solutions, sorry, there was stuff in my way. Types of solutions. So you can have one where they cross once. Let's go right here. So that is one solution, because they cross once. And then I would write the answer as -2, comma, -1. You can also have no solutions. So no solutions looks like this. That's no solutions, because they never cross. So parallel lines never cross, so they'll never have a solution. Because remember, it says when they're equal. So this line is equal to this line when they're crossing. They have both the same x and y value. So that is why we call it a solution. And then the last one is an infinite number of solutions. And that looks like this. And so it's actually 2 lines on top of each other. I just am putting it next to it so you can see the 2 different colors. So this is infinite number of solutions. Because they're on top of each other, they have the same solution all along that line. So they have a value of -1, 2. They all have a value, or both lines have a value of 1, 2, -2. So that's why it has an infinite number of solutions. Okay. Now, the main way we're going to do today is by graphing. So solving systems by graphing. So if I gave you the equation y equals -2x plus 1 and y equals 2x plus 3. So if you look at those 2 lines, they're not exactly the same, so they're not going to have an infinite number of solutions. If they were exactly the same, it would be the same line. Okay, so let's go ahead and graph it by hand, and then I'll show you how to do it in your calculator. Okay, remember this -2 is the slope. Sorry, I had to sneeze. And then this 1 is the y-intercept. So I'm going to go up 1, and then my slope is -2 from there. So I'm going to go down 2 over 1, down 2 over 1, up 2, back 1, and that would be my line. Okay, that's my first line. Then the next one is has a slope of 2 and a y-intercept of 3. So this is a y-intercept. This is the slope. Remember, always start at the y-intercept. So 1, 2, 3. And I really did not make my graph big enough. Sorry. And then go by the slope. Now it's a positive 2, so I would really go up 2 over 1. But since I'm out of room, I'm going to go this way. And I need to cross this line anyway. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. Okay, that really is not the best line just because I know what the solution's already going to be. But let's go ahead and look. So sometimes you're not going to be able to see it. You know it's somewhere between 0 and 1, and then it's up from, what am I trying to say? It's somewhere around 2. So we're going to graph it. So y equals negative 2x plus 1. Remember, put both equations in the y equals. That's what's so awesome about these graphing calculators. Then 2x plus 3. Hit graph. Okay, you see them cross, kind of like how mine did, just make a big X. Now, just like the other day whenever you found the max and min, when you found the zeros, if you hit trace, second trace, sorry, and go down to, notice you have value, 0, min, max, intersect. We want the intersect because remember we're looking for where the two solutions are, or the two systems are the same, so where they're crossing. Now it will say first curve, hit enter, second curve, enter, and then of course it has the guess, so hit enter again. It doesn't, for the intersect, it's so much easier than the zeros and the min and max. It doesn't matter where on that line, so I'm going to go through that again. It doesn't matter where on that line you're at, so I could be way over here, I could be way over here. It really doesn't matter, so I just hit enter, enter, enter wherever it's at when they're both linear. I'm going to do a quadratic one and you'll see that it's a little bit different. So here's our solution. It is at negative 0.5, comma 2. Again, give the x value, then the y value. Okay, I'm going to do another example. So if we have y equals x squared plus x minus 2, and y equals negative x plus 1. Okay, I'm not even going to graph it by hand that time just because it's a quadratic. I did have a question where somebody asked, do we really know how to graph this yet? No, and you can't do it based on transformations because remember the transformations were always set up in vertex form where it was x minus some number squared plus some number. The next unit we're going to be talking about how to get this into this form, but you cannot just graph that based on a transformation. So here we go. So I'm going to just go ahead and graph it in my calculator. So x squared plus x minus 2, oops, it doesn't matter the order. I'm just going to use red and black. Negative x plus 1. Okay, hit graph. Now we know this one's going to be a parabola because it's squared. So, and I'm just going to draw a quick sketch just so that we can see it. So we have and then we have another line that goes down like this somehow. I told you it wasn't going to be a good drawing. But so again, do the same steps. Hit the second trace button. Let me go ahead and write this out. Second trace. Go down to number 5, which is intersect. Now, this is the only one where you have to actually move the cursor. You just want to get it close to the zero or to the intersection that you're trying to find, since there's two of them. So the first one is at 1, 0, and then your second one is at, so second trace, go to intersect again. I forgot to write these, finish the steps. So now I want to find the other intersect, so I do need to kind of move closer to it just so that I'm telling the calculator which one I'm looking for, and enter again. So the next one is at -3, 4. So those are our solutions. If you're looking at a graph, you will have a few that you just look at the graph and find the intersection. You would just, like if it was crossing right here, you would say 1, 1. You just look for where they're crossing. Okay, so solving systems, again, just find where they are intersecting or where both of the values are the same.